Hello, everyone. It's good to see you here. And I think this room is probably too big for the audience, but I think it's kind of expected because I think there are not so many people that pay attention to testing, especially the testing for big data applications. It's a field that is very ignored in industry, but I think as you scale out your applications, and you will start to be aware of the importance of how you should test your applications and how you should think about this problem. So I've been working on big data problems for over 10 years. So I think this talk is more about a summary of the things that I have learned from my own experience and from my experience working with different data practitioners and machine learning practitioners. Maybe there are things that you don't fully agree with, but I hope it can be inspiring. Thank you. So before starting, I would love to have a quick survey, like how many people are using Spark? If you use Spark, raise your one hand. If you also do non-ad hoc test on Spark logic, raise two hands. Okay. I think not many people are doing non-ad hoc tests on Spark. I understand the pain point. I will talk about it. How about Dask? How many people are using Dask? And how many people are doing non-ad hoc tests on Dask? Oh, I see. And how about Ray? How many people are using Ray? Good. And non-ad hoc test? Okay, good. I think it's good. I know it's a pain point. It's very difficult. And I heard about this type of complaint almost every day because I work with a lot of data practitioners and machine learning engineers. So in today's talk, firstly, I want to have a quick introduction to the testing types and to discuss the purposes of those tests. And then I want to talk about the mindset to when you design a big data application and to see how that can affect the testability of your applications. And then I'm going to talk about the good practices for testing. In the end, I'm going to introduce Fugue and see how Fugue can help in testing your applications. Let's start. So there are two main purposes for testing your software and services: to verify the correctness and performance. On the low level, we have unit testing, integration testing, and regression testing. And regression testing can be in the form of unit testing and integration testing. And on the high level, for correctness, normally you do acceptance testing. And for performance, normally you do stress testing. And for stress testing is mainly for throughput and latency. And for acceptance testing in the context of big data, people normally do spot check or data validation. I will talk about it later. So talking about the testing strategy, if we just pick unit testing, integration testing, and acceptance testing, from top down, we move from implementation focused to data focused. We move from technology driven to business logic driven. And if we talk about the benefit of in the context of big data, then we will see that the higher level testings, they're easier, faster, and cheaper because they do not require so much context of the distributed system. And of course, the higher level testings, they have better coverage. So the purpose of the strategy of testing is you should try to move your testing logic to upper level as much as you can. But of course, every layer will have their own purposes and you should keep all of them. Every testing is important. So now let's talk about the mindset. When you design your big data applications, how that can affect the testability. The first thing, you must have a strong sense of separation of logic. So in my opinion, there should be layers of logic. The first layer should be your core computing logic. It should be framework agnostic. And this part should be the most unit testable part. And it should be well covered by unit test. On second level, I call it orchestration logic, or you can call it something else, but it's framework dependent. Framework, I mean Spark, Dask, and Ray, or any other distributed backends. And this one, so if you use Spark, Dask, and Ray, actually it's testable. But the problem is sometimes it's very slow to test. For example, Spark is the typical example. If you want to start a local Spark cluster and test some simple logic, it's probably fine. But if you have hundreds of such tests, it will take very long time to finish. Why I know that? Because I'm the creator of Fugue. And in Fugue, in order to cover everything, we have to have hundreds of unit tests just on Spark, Dask, and Ray. It takes very long time to finish. So the last layer should be framework-specific logic, including how you set up the cluster, how you tear down the cluster. This is purely like an infrastructure-oriented logic. It's the most difficult ones to test. So if you want to test, probably you should cover that by acceptance tests. Now let's take a look at an example to explain the separation. So we have a data frame, and we want to group by G. And then for each group, we want to subtract the mean of V from V. So it's a very simple example, right? So if we want to implement this in Spark, here is an implementation. As you can see, to be honest, this is a very bad implementation. Why? Because there is no separation of logic. As you can see that in this function, you create a Spark cluster. You try to initialize the Spark cluster inside this function. And another thing you have to be aware is you try to use a lambda function to do the group by apply semantic. But this lambda function itself is actually totally Spark independent, right? So if you design your application in this way, then it's impossible to do the simplest unit testing. Probably you can do some integration testing, but it's also very difficult. What you can do is acceptance testing. And maybe, I think what people commonly do is just do some spot check. So this is a very bad design. In order to solve this problem, yes, it's a little bit more code, but this code is in a much better shape, much better structure. And you can see that for the first part, your core computing logic has nothing to do with Spark. You should fully cover this with unit testing. And for the Spark-dependent logic, you also move out the creation to the third function. And in the Spark-dependent logic, you just try to distribute the data frame and the method and to run this distributedly. Right? So with this design, you have separated to 3 layers. And you can do unit test on the first layer, integration on second, acceptance test on the third. So it's a relatively better design. But I will talk about if there can be an even better design later. The second mindset I want to say is you should try to avoid the framework-driven mindset. So I talk about 3 layers, but actually you should always try to maximize the framework agnostic layer where you can do all types of unit testing. You should try to minimize the framework-dependent layer so that to reduce the size of integration test. And for framework-specific logic, of course, you want to minimize it. But more importantly, you want to standardize it, and you want to centralize it. So you do not have to have too many acceptance tests to cover that. So let's take a look at another example. We have a custom logic here. We want to process this data frame. It has 4 columns, A, B, C, and D. They're all strings. There are some nonce. So for each row, if there are more than 1 non-null values, we will sort these values, concatenate them, and put them into the column E. Okay? But if there are too many nonce, we will just drop this row. So this logic is very specific, right? But the question is how we implement this. Okay, so if we want to use Spark to solve this problem, the first thing came to our mind will be using map partitions, right? If you want to use map partitions, you will have to implement a function with the iterator of rows as your input. But the problem is, as soon as you write this function, you will notice your core logic now is tightly coupled with Spark. no matter when you want to test this core logic, which represents the business logic, you have to have a Spark cluster, even locally, either locally or distributedly, right? So you do not have a good separation of logic. It's not very unit testable. If you want to implement this using Dask, and Dask is pandas-like. So the first thing came into your mind, probably I should use pandas supply. Right? If you use pandas supply, okay, the logic should look like this way. And the input will be a pandas series, because this is required by a pandas supply. And it looks better, because this core logic is totally unit testable, and it has nothing to do with Dask. But the problem is, the core logic does not cover everything of your requirement. If you look at here, the filtering logic is left out of your core logic. So in order to test things end-to-end, you still have to have an integration test on my app in order to test the whole logic. If you want to implement this on Ray, now it looks much better because Ray is not like Spark or Dask. It's new. It has very few options. So you think less. And you can only use map batches on dataset. And in map batches, very nicely, they can take the pandas data frame as input and output, and they will just distribute this core logic to different data frames. And when you have this requirement, you will find, okay, now I can write very modularized code. Right? The input is just a subset of the entire data frame as the pandas data frame. And then I just write this very pandas native code to solve this problem. Right? So now, if you look at this structure, it is much better because this core logic is a full representation of your business requirement. And the framework dependent part is very minimal, right? Looks very optimal. And to be fair, if you know more about Spark or Dask, they also have special API to take this pandas data frame. And they also have the similar function like map batches in Ray. So it's not the only advantage. I mean, it's not an advantage of Ray. Actually, every distributed frameworks they have, right? But is this the best solution? So now let's take a look at alternative implementation of this core logic. Still pandas data frame in, pandas data frame out. But here, what we try to do is actually we just try to wrap this process function. This process function just takes, very simple, just takes an iterable of list as input, iterable of list as output. Then what you can find is, I only need 4 lines of code to solve this problem. It has no dependency on any framework. Very expressive, very simple, right? The things you have to do is the data conversion. You have to convert the data frame to a 2-dimensional array and then process and construct it back to a pandas data frame. Why I put this logic here? If you compare the speed, it's a surprise, right? Pandas native approach is 50 times slower than this Python native approach. So it's a big surprise, right? So if we take a step further, just think about it from the very beginning. If you don't know pandas, if you don't know Spark, Dask, and Ray, what will be the first thing coming to mind? Actually, it is this function. Because this function has nothing to do with any package. Simple and expressive is also the fastest version. But what prevents us from having this idea at the first, as the first idea, right? So I think the problem is we are so distracted by frameworks we are going to use. The common thing I see from the data practitioners are, if they want to solve a problem, the first question is, how do I use XYZ to solve the problem? But I think if we can change our mindset, what can we do as much as possible before using XYZ? I think that kind of mindset is healthier because it's more business-driven. So it can help you to isolate your problem, just to focus on solving your business problem instead of like getting distracted by the special features of different frameworks. That is, at least to me, I think it's a very useful mindset. When I made that change, I find my programming skill improved a lot. Okay, now let's talk about good practices. I know a lot of people talking about NYC taxi in this conference because it's New York City. So again, I'm going to use this example, but no technical details. So the background is, this is a public data set, and the data date ranges from 2009 to 2022 on a monthly basis. And each file represents a month of data. The size ranges from 50 to 150 megabytes. And each file contains 20 columns. We only need 2, which are shown here. And each row represents a write. And there are 242 different locations in this PO location ID. What we want to do is, for each PO location ID, we aggregate the data to get the hourly total number of pickups. So it's a time series. We want to use that time series to train a forecasting model and to predict the next horizon, the total pickups in the next given horizon. Okay? So given that in mind, here is a high-level workflow. It's very simple to implement this task, like get 1 month of data, aggregate by location and hour. Like for example, if you do that in pandas, probably it just takes you a few minutes to do that, right? So, and then you just want to merge everything and repartition by location and sort by hour. Now you have, for each location, you will have a time series. And now for each location, I can just train and predict distributedly. And in the end, we just merge the predicted value and save to a file. So just given this workflow, I think I can call this big data workflow. Although, I mean, it's just, if it is several hundred gigabytes, I think it's fair to call it's a big data workflow. How can we test it? So this is what I commonly see from the people I work with. So because getting 1 month of data, aggregate location and hour is pretty trivial, probably just a few lines of code. And given any decent distributed backend, Spark, Dask, and Ray, they all have very simple method to run this distributedly on the full history. People tend to run this, like implement this with a few lines of code, and then run full history immediately. After they run the full history, they just do ad hoc spot check, okay? And then feel, oh, it's good, it's good. Then what do? They just write the whole bunch of code and to finish the pipeline. Okay, after this, what they do, they just run from the very beginning, run the whole pipeline, and then do another spot check. If it is good, they will just say, okay, I have tested this application. It works good, let's ship it. But when you ship it, you don't even have any written test, right? Everything is ad hoc. So this, and another thing is worth to mention is that when you run things in full scale, it's not take like seconds or minutes, it can take hours. But with this kind of like a design, then every time if you have any problem, you find out in your spot check, you have to restart from the beginning. The iteration is actually a lot slower. And also think about using a cluster to run this can also be very expensive. So it's not a good way to develop your application. It's not a good way to test. It's not optimal. Now let's talk about a better strategy to do this. So getting 1 month of data aggregate, it's trivial, right? But it's also trivial to add unit test, right? So why not just immediately add a unit test as soon as you finish this local logic implementation? It's not hard, right? And for the second step, union data, repartition, and sort. This one, you can just provide some mock data and then to assert on the output. So for this step, it's also trivial, right? So you should also write a unit test as soon as you finish the implementation. A third step, train and predict for one location. So you have 2 ways. One way is just to get 1 month of data of a certain location, and then maybe save that as a file for testing, and then you can just load that file here and to do the test. Or you can just manually construct some data for testing, right? It's not difficult. So you can have another unit test here to cover it. And all these tests, if we run them, it shouldn't take a few seconds. But think about that. If there is any problem in the implementation, you quickly turn around because you can quickly make some changes and run the unit test again. So iteration is much faster. And after you get everything together, now you want to chain them together, right? So wait, let's do one more month of data. Just do one more month. So now this first step is multitask. And let's pick one more location to do train and predict. Now this step is also multitask. Now let's implement the union or and save. Okay, this is an end-to-end pipeline now, but you are not processing a lot of data. It's still very limited amount of data, end-to-end. So at this step, what should we do? We can add an integration test now. So think about that. The integration test is testing this, although not at full scale, but structure-wise, there is no change if you want to run it full scale or partial scale, right? So at this step, this is the best time to have an integration test. It will also give you very fast iteration if you find any problems in it. After you finish this integration test, let's first do the full test, like a full run of the first step. And here, instead of spot check, I strongly recommend you add a data validation step in your workflow. Always prefer data validation because why? The data validation has so many benefits. One major benefit is that when you add this to your workflow, the validation not only happens before your production, it happens during your production as well. So you always have that kind of protection, right? And this data validation should be like a data contract, a description of a data contract. And this data contract will guarantee that the bad data will not flow to the next step. And then you just run the full scale on train and predict, have another data validation step as acceptance test. So to summarize, best practices. First of all, I want to say, try to be test-driven. I know it's very hard. It's very hard. People feel it's very challenging to change that mindset, to change that development style. But try. I did pure test-driven for 1 year. It's just amazing experience. You will get very slow from the beginning, but then you will get faster, faster, faster. And in the end, you don't fix bugs. You just keep creating new things and just enjoy the development experience. Second thing, I think you should always try to unit test the small data and the core logic unit. You should do integration tests before running at full scale to save time and money. And you should try to add data validation steps in the workflow as your acceptance tests. Spot check is useful, but you should standardize it. And I think for big data problems, data validation is the most reasonable way. Okay, and the last but not the least, I think tests should reflect the requirement of each logical unit. It should be the most readable part of your code. So try to make the test just like a document. It will be very beautiful. Okay, so I talked about mindsets and good practices. Now the question is how to enforce the good practices, how to have a very healthy mindset. So here I want to introduce Fugue, and I hope it can help you shape your mindset and also to enforce some of the good practices. So Fugue is a unified abstraction of computing frameworks. So on the local side, we have different computing frameworks. We have SQLite DuckDB as the SQL solution. We have native Python. We also have Pandas. On the distribution side, on the distributed system side, we have Spark, Dask, and Ray as the major players of distributed solutions. Fugue is just a bridge between local and distributed environment because it has the abstraction. So it unifies how you use the different computing frameworks. And you can just use the exactly same logic, same expression of your logic on small data using local execution engine, or you apply that on big data on a distributed execution engine. So Fugue guarantees the same behavior on different environments. So what's the value of Fugue in terms of testing? It removes the framework-dependent logic. So remember that we talk about we should have 3 layers of logics when design, right? We should try to minimize the first layer, maximize the first layer, minimize the second layer and third layer. What Fugue can do, it can simply remove the second layer. So instead of having a framework-dependent layer, now everything is framework agnostic. The Fugue abstraction itself is framework agnostic. So remember that it has a unified interface for local and distributed. You only need to use that abstraction to run on a local engine. Then you can do the unit test. So when you test your distributed logic, you do not even need a distributed environment. So it gets rid of the need of an expensive environment for unit testing or integration testing. So let's recall the first example. We have 3 layers, right? And the problem is, for this My app, we still need to have a Spark cluster to test it. How can we improve this? So what we can do is, instead of writing the Spark-specific code, you just import the transform from Fugue and rewrite it in this way. Notice now the input of my app becomes a df, which is any type. And engine is also an any type. So what does that mean? That means now this app is framework agnostic and scale agnostic. So if we want to unit test it, just input a pandas data frame. This transform will just return a pandas data frame. You can just use this to test your logic, just using a local environment. But if you want to productionize that, you want to scale out, simply provide the Spark session you constructed, or Dask client array. And you can also replace this data frame from a pandas data frame to a Spark data frame, Dask data frame, array data set. They all work. So the transition and the data conversion are all handled by the Fugue level. And the Fugue level is well tested. We always maintain 100% test coverage on our side. Okay, so that means with this implementation, you no longer depend on any specific distributed backend. Look at the second example, customer logic. This is simple and fast, right? How can we scale this out? Again, you only need to add 1 line of code. Still the transform function. So what's the magic here? So look at the first function, the subtract min. The input is pandas data frame, output is pandas data frame. The second function, input and output are iterables. So actually, what Fugue can do is, as long as you have the type annotation, Fugue knows how to do the data conversion. For example, in this case, if this my app is running on array, it will also use map batches. But the data conversion part you have seen in the previous example is automatically handled on the Fugue level. So you don't have to really write those kind of boilerplate code in order to adapt to your most expressive and the most reasonable implementation. You just focus on the most reasonable way to do your thing, and Fugue can adapt to your way. So that's the magic of Fugue. If we take a look at the third example, the major benefit is until the integration test, even we finish the integration test, we may not need any distributed backends. So everything would just, you can just run everything locally without the distributed backends. And the behavior should be exactly the same when you switch that to like Spark, Dask, and Array. And on the validation step, actually I gave a talk last year on PyData Global, how you can use Fugue with Pandera and the Gray expectations to quickly scale out those data validations. So maybe you can use that as the additional step to do the distributed data validation at the beginning of each major steps. So beyond that, let's talk about SQL. So we all know that SQL is not very unit testable, right? Spark SQL, I guess no one is testing it. Especially when your SQL source is not even a local data frame. Think about that. This is very common in different companies. I just want to select something from a Hive table, but I actually add a lot of logic to this SQL. Right? So now the question is, how can we test this? This is not testable. People, I think the excuse is that the source is just a Hive table. It's not testable. But actually, if you use Fugue, this is fully testable. What you can do, two things. One is, because we can fully understand the SQL, so it's mockable. You can just say, okay, I want this Hive.source table to be something else. You can just provide a pandas data frame. And another thing is, instead of running this on Spark, you can just run this on DuckDB. Now, the logic is actually executed on DuckDB, and the source hive.src table is already the mock table, the pandas data frame. So the output will also be a local data frame, either arrow table or pandas data frame. You can just do the local unit testing on it. So it's fully unit testable, even not without Spark. And here is an advanced example. So this is something that Fugue users often do. It's called Fugue SQL. Fugue SQL is a SQL that's beyond the standard SQL, the traditional SQL, because we can have extra syntax to invoke those Python functions as the extensions. Advanced UDF idea. And what you can do is, as the first step, you just still get the data from Hive. And the second step, you want to pre-partition by location and pre-sort by timestamp, and using this train predictor function on each of the partitions. And this train predictor function itself can just be a very independent pandas function, and you should fully unit test it. Now the question is, how do you test this without even using Spark? This is like integration test, right? You have to do an integration test end to end without using Spark. How can we do that? Again, you can just use this fsql, and you can mock the input, have src table, and just provide the path, a local path. And then you just run this on DuckDB. After this, a local file will be written, and then you can just assert the data in the output file. So to be honest, this is still not perfect. For example, for this data trunk, this function, luckily, for both DuckDB and Spark, they have the same signatures. But if there are some other functions, it may not be compatible. But the bottom line is, you can just run this on a local Spark. It's not perfect. Now you have to get Spark involved to test your logic. But at least the input data is much smaller, and you can do some sort of integration test. Otherwise, you can only do acceptance test because this input is a Hive table. So what Fugue can do is try to push your tests up to upper levels as much as we can. Yeah. Okay, so in summary, all types of tests are useful for different purposes. We need to be strategic about that. And application design really matters. You should try to separate out the framework independent logic and minimize the dependent part. This is the mindset. And you should not be driven by tools. Tools is working for you. You are not working for the tools. And Fugue can reduce the dependency on distributed backends and simplify and accelerate the big data pipeline testing and iteration. But again, also Fugue is also a tool. So, even you are interested in this, I think don't driven by tools always holds. I hope whatever you do, try to start with a fresh mind. Thank you.
We have 5 minutes for Q&A.
Yes, please.
One thing, of course, working with big data is that very often it's far from perfect. And one of the advantages of the spot checking method is that if there are small imperfections at the beginning of the data, but they don't affect the aggregate output, so you don't get distracted by them. With unit tests, is there some concern that you will get distracted by a lot of bad data that doesn't really impact the output that much?
Okay, so I think your question is because big data has a lot of noise. So small data, if you just test on the small unit, you could get distracted by a lot of noises. I think this is a valid thing. First of all, if you know that your data has a lot of like noises, you should have different layer of tests, like higher level tests, like for example acceptance tests, things like that. They should be more resistant to the noise. And on a lower level, I would say that why not just intentionally add some noise and see how the system react to those. I think it could. It's to me. I think adding noise to the test case is a very good test case that we should test. That's just my opinion. Yeah, I don't think it's a bad thing, to be honest. Thank you. Yeah, please.
From your unit tests in Spark, you use RDDs?
We don't use RDD. We just only use data frame. Yes.
Yeah, that was my concern because in the example you make like a map reduce unit testable function.
So RDD, to be honest, is not the first class citizen of Spark. In the Fugue framework, we try to make that more clear that data frame is the way to go. Actually, this is also what Spark suggests people to do. Try to do your things in data frames. Like if you try to use RDD, it's a sign that maybe you should think more about, think twice and see, okay, should you use RDD or should you use data frame? So I think so in the Fugue world, it will not let you use RDD. Yeah, RDD is a special concept of Spark.
But in your example, you were using map reduce function. So what do you use in Fugue?
So using Fugue, so let me see.
You're talking about the RDD map partitions.
Map partitions. So in Fugue, we have two ways. One is we will convert to RDDs, and then to do the things I showed. And another way is if you enable pandas UDF, we will just use pandas UDF, which is a new way. It's much faster than map partitions. Yeah. So internally, yes, sometimes we have to convert to RDD to process, but we will prefer pandas UDF.
But is there a way of entirely skip the RDD functionality because
best effort. Sometimes we cannot skip the using of RDD. Yeah. It's not always. Yeah, but I think in most cases, we can totally skip using RDD. Yeah. Yes, please.
That last example you had was sampling of the test data. Does Fugue support any sort of
Sampling
of test data? Just give me the hypes label and then I sample it for you and then I give you so
that
feed it into your integration.
That is a very good question. Actually, I didn't show the iteration. Actually, sampling is a very important technique when you want to do big data application testing. Sorry, I didn't mention it, but thank you for the reminder. So what we normally do, in the practical situation, I will separate this pipeline to two parts. And the first part, I will just maybe sample like 0.0001% to get a data frame. And then in the second part, I will continue iteration. So sampling is a very important technique to break the lineage and also to provide the smaller data for iteration on the next step. Yeah, thank you.
Is it included in the Fugue library?
Yes. And it's often used. Yeah, it's often used. Okay, thank you very much.